Today we're going to learn a new class. This is the class 6, and it is called Solving and Graphing. Linear inequalities. Inequalities. Okay. Before we start that, we're going to do a quick review. If you can remember, we learned in class 3, 4, and 5. All of them are about linear equations, not the inequality, but linear equations. So for the class 3, we learned how to solve. Okay, solving linear equations. So if you want to review, then you can go there to look at my video on class 3. So this is you know how to solve for 2x minus 5 equals 13, this type of question. And then for class 4, we learn how to graph. So that is graphing linear equations. And we learn how to graph y equals 2x minus 5. Okay, we pick 2 points and we can graph that, just connect them. Or you can use the slope and intercept. And C5 is, I give you some condition, can you write this linear equation for me? So that class is called writing linear equations. I give you intercept, y-intercept and the slope, or I give you 2 points. You figure out the slope first, and then you use the slope and 1 point. You can have the slope point form, whatever method you want to use, as long as you can give me that linear equation. And there are several forms of it: point slope form, slope y-intercept form, and a standard form. So this is everything we learned for the previous 3 classes. They are all about equations. And today we're going to do linear inequalities. Inequality. Inequality means not equal, right? It's not equal. So I'm going to teach you some concept about the inequality and number line. You probably think, well, I already know the number line, which is a straight line, and you just put the numbers there and then you can find the number. Now let me show you how to show an inequality on a number line. So the inequality would look like this. Let me give you one example. X is greater than 5. This is an inequality. All right. So if you want to show that x is greater than 5 on the number line, and that's x. And in the US math book, they also put an arrow here, but in Chinese math book, we don't have that. It just shows it's greater, and it gets greater and greater to the right. But in the US math book, it shows this number line can be extended to both directions. It doesn't really matter. It's pretty much the same thing. So 0 and then 1, 2, 3, 4. Here's a 5. Okay, here's 1. And usually I also put a -1. This is a number line. How do you show the x value that is greater than 5? Here's a 5. So any number, any x value greater than 5 will be from 5 all the way to the right. So if you want, you can just show this area, this just make this line thicker. Or if you have a different color, like red or blue, you can just use different color to show that. Now the tricky part is 5. Because this is x is greater than 5, x cannot be 5. If x cannot be 5, we put a little circle here. This little circle means it cannot be 5. It's not 5. So 5, no 5, only above 5. That's how you show this inequality. Now, what about x is greater than or equal to 5? Is there the difference between two? This one is greater than 5. This one is greater than or equal to. So either 5 or more. Then when you show this, here's a 0, here's a 5. Okay, again, greater than 5. That's here, right? Greater than 5. Because x is greater than or equal to, so we put a solid point around this point. So that is greater than or equal to. So easily you can see the difference between these two. This one has a circle because it cannot be, and this one is it's a solid dot. A solid dot at 5, so that means it could be. Therefore, x is greater than or equal to 5. You know you're going to have a solid circle, but it's greater than, and then that's going to be a little circle. All right. What about this? Let me give you one example. What about x is less than 5? All right. Let me just do this US way. X. Here's a 0. Here's a 5. How do you show that x is less than 5? Here's a 5. So from 5 to the left, every single point on this number line, that the represented value will be less than 5. So we should just mark this part. However, because it cannot be 5, so it's going to be a circle here. And then that's your answer. All right. Now the next one will be x less than or equal to 5. I think you're super smart. You already know what to do. Right? Here's the x. And here's a 0. Point is 5. Less than or equal to 5, a solid point. And then put a mark on this part. So this is less than or equal to 5. Okay? So this is the basic concept about the inequality and the number line. And we always want to show the inequality in the number line because it's very, very straightforward. You can see that, you visualize this inequality. Okay? Remember in class 3 we learned how to solve a linear equation. Now we're going to solve the linear inequality. Solving linear inequality. So we're going to do a lot. All right, now let's review a little bit. What are the method we learned how to solve a linear equation? We learned plus, minus, multiplication, and division, those rules. So what we were doing is if A equals B, then, if you remember this, A plus C equals B plus C. So on both sides of the equation, you can just add the same amount, or the same thing, A minus C equals B minus C, right? So on both sides of the equation, you can add or subtract the same amount. Multiplication, if A equals B, then A times B is the same as, A times C. Here, A times C will be the same as B times C, and of course here C is not 0. Okay, if C is 0, it's also equal, but that's not what we want. And divided by means A over C equals B over C, and that definitely here that the denominator cannot be C. So this is the rules or the properties we used for solving equations. This is the properties of the equation, which is you either add or subtract or multiply by or divided by the same amount, only the last one, that amount cannot be 0, then you get, again, this equation still holds, or is still the equation. So you can do the same thing on both sides. To solve a linear inequality, we have something very, 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 very similar. And if you have A either greater than or greater than equal to, less than or equal to B, then on both sides of this inequality, you can add or subtract the same amount. Let me write it. Okay, I'm going to write the first property, the first two property. It is like this: if A is greater than B, then A plus C is greater than B plus C. So if A is greater than B, A is a bigger value, and then C is a smaller value, and then both sides, if you add the same amount, then you still have this inequality, and the direction of this inequality symbol doesn't change. And of course, A minus C will be greater than B minus C. All right. Now, if A is greater than or equal to B, then same thing. A plus C will be greater than or equal to B plus C, and A minus C is greater than or equal to B minus C. What does this mean? That means if you have an inequality, then on both sides you can add or subtract the same amount, and you're going to keep that inequality sign. Okay, so of course usually the book give you all the situation, and then it should be the same thing. I believe you should be able to do this by yourself. If A is less than B, then I just write plus minus C will be less than B plus minus C. Of course, if here's a plus, here should be plus, here's minus, here should be minus, and you still have this less than sign. And of course, if A is less than or equal to B, then A plus minus C will be less than or equal to B plus minus C. This is very obvious, isn't it? But once we know this, we can solve a lot of inequalities. Before we go ahead, let me talk about multiplication and division. Do you remember when you have an equation A equals B, then on both sides you can multiply by or divide it by the same amount? Of course, the denominator is not 0. Then you still have the equation. However, for multiplication, it's different. So if A is greater than B, then AC, you think it's going to be greater than BC when C is positive. So that means you have an inequality, and then for both sides you can multiply by a positive number. You keep this sign, and then you have another inequality. But AC will be careful here, will be less than BC when you multiply by a negative number. You multiply by a negative number on both sides of an inequality, you're going to switch the direction of this inequality sign. So I don't know if I need to write everything here. Let me just do it. Okay, then same thing, we just everything here, all the situations, which I don't think is necessary. So when C is a positive, if A is greater than B, then AC will be greater than B. And then AC will be less than or equal to BC when you multiply it by a negative number on both sides. Now, quick question. What happens if you multiply by 0 on both sides? If you have an inequality, you multiply by 0 on both sides, you get an equation, isn't it? You get a 0 equals 0. So usually we don't care about a C equals 0 situation here. But for the equation, if you have A equals B, if you both sides multiply by 0, then you get a 0 equals 0. It still holds, it's still an equation, but it doesn't help in terms of solving A equals B. Now, next one. If A is less than B, then AC is less than BC when C is positive. I just read that, it's easy. And AC, I change the direction of this inequality, and when C is negative. All right, now the same thing, if A is less than or equal to B, then AC is less than or equal to BC when you have a C positive, and AC is going to be greater than or equal to BC when C is negative. This is really, I don't really need to write everything here, but I still did. All right, so this is all the situation you're going to have when you want to multiply by a number on both sides. Let me just finish this, make it a little better. Now, of course, you can imagine that when you multiply by a positive number, then that inequality still holds. You still have the same direction of that inequality sign. But if you multiply by a negative number, then you have to switch the direction of the inequality. This is when you multiply by a number. And the same thing, if you want to divide it by a number, you should have exactly the same rule. And I just spent some time to write it. Okay, if A is greater than B, then A over C is greater than B over C. All right, now this one when C is positive, okay? And A over C is less than B over C. That is when you have C negative. When you multiply by 1 over C, which is the same as divided by C, so when C is positive, then 1 over C is positive. That's why we have exactly the same rule for multiplication. And I don't think I need to do that. Well, I'm lazy, so I just write equal to. So here we'll have an equal sign here, okay? And if A is less than B, then A over C is less than B over C when C is positive, and A over C is greater than B over C when C is negative. So the difference between this one, of course I can do this, the difference between the rules when we solve the equation and the inequality, the only difference is somewhere here. When you multiply by a negative number, when you multiply by or divided by a negative number, you have to switch the direction of your inequality sign. Okay, so we are going to use several examples to show how to use all the properties we just did and to solve the problem. Now, question number 1. Okay, question number 1. Let me see. X minus 5 is greater than 7. How do you solve this inequality? And we have this x minus 5. If we have x minus 5 equals 7, do you remember we did this in chapter 3, in class 3? We just add 5 on both sides. So in this situation, we do the same thing. We plus 5. Okay. Therefore, we have x, because this plus negative 5 canceled out, and we just add or subtract. You don't change the direction, so it's still greater than, and the right side is 12. We have the solution. So if you want to show this, that'll be 0, and here is 12, and it's a circle, and then you mark the area. You mark this part to the right of it. So that's your answer. Okay, that's number 1. So what about this? Number 2. X minus 5 is less than or equal to 2. We use a similar rule. We add or subtract an amount to both sides, and we still have that inequality. So we plus 5. So I will have x is less than or equal to 7. Right? Then we have x and a 0 and a 7. Okay, less than or equal to 7. The good thing, I always put a solid point because I have this equal, and then less than, that means to the left. See, it's pretty easy, isn't it? I already used the rule to solve this inequality. That's the second example. And then let's work on example number 3. Example number 3. What about this one? -1 greater than or equal to x minus 2. Well, this one is a little different than the previous two because I have an x on the right side. It doesn't matter. Let's get rid of this -2 first by adding 2 on both sides. So I have 1 greater than or equal to x. 1 greater than or equal to x is equivalent to x is less than or equal to 1. Okay, I hope you can be familiar with this. It doesn't really matter when you solve the problem. For the equation, remember you might have the x on the right side and you have a number on the left, and you can easily just switch that. But for inequality, if you want to switch both sides and make sure that you have switch the direction of this inequality sign. So we have x, and here is a 0, and here's 1. X is less than or equal to 1. It's a solid point, and then we're going to mark the part to the left of 1. So we solved it, and this is our solution. One more, number 4. What about 5 is less than negative, let me do x plus 1. And very similar to the one we did earlier, we just subtract 1. So I have a 4 less than x, and it's equivalent to x is greater than 4. Okay, 4 is less than x, which is equivalent to x is greater than 4. So we have a 0 and a 4. And we're going to draw a circle because there's no equal here. So that's greater than 4. That goes here. Got it? See? We use the rules we have, and we already solved 4 inequalities. Now let me do more. Number 5. This one. X divided by 3 is less than 2. Well, we cannot just add or subtract a number. You just think about when you work on equations. If you have x over 3 equals 2, what are you going to do? You're going to multiply by 3 on both sides. So in this case, we can multiply by 3. And this 3 is a positive number, so we keep the direction of it. So I'm going to multiply by 3 on both sides. Then 3 over 3 get cancelled out. So I have x is less than 6. That's my answer. X is less than 6. Okay, so you multiply by 3 on both sides. So this is x, 0 and 6. You're going to have a circle. Add a 6 because there's no equal sign. And then just mark this part. Okay, number 6. Negative 2x is greater than 8. Negative 2x is greater than 8. Again, you think about how do you do this when you solve an equation. You divide it by -2, right? But when you solve this inequality, you have to be very, very sensitive when you multiply by or divide it by a negative number. So when you divide it by -2, okay, on both sides, you divide it by -2, you will need to change the direction. So negative 2x over negative 2x divided by -2, you have x, and you're going to change this to that. Okay, this is the key. A lot of people make a mistake here. They forgot to change the direction. 8 minus -2 is -4. So that's your answer. X is 0. Here's a -4. X is less than that. So we have a circle, and then we just mark this part. X is less than -4. Now this is important. When you multiply by or divide it by a negative number, then you have to change the direction. Okay, let's work on a couple of more. All right. if I do, this is number, I forgot, this is number 6. Now the next one is number 7. Let me give you an easy one first. 5x greater than 10. Did you notice that when we try to solve the inequalities, we always think about how did we do that when we solve the equations, right? So like this one, when you solve the equation 5x equals 10, then you divide by 5. And this one, same thing, you divide it by 5. Divided by 5. You are divided by a positive number, so this direction is still the same. Then we have x is greater than 2. And of course, when you graph, here's a 2, and it's a circle, and then mark the right side to it. X is greater than 2. Okay, what about the next one? 8. X over negative 4 is greater than or equal to 1/2. Again, you think about how did you do that when you have to solve this equation. X over something equals to another number. You multiply by that number on both sides. You multiply by this denominator. So you're going to multiply by negative 4 on both sides. You're going to multiply by negative 4. And be sensitive to negative, okay? So when you multiply by negative 4, you have to change the direction. So x over negative 4, you multiply by negative 4, it gets canceled out. You have x, and then you change the direction, okay? And 1/2 of negative 4, which is negative 2. So that's your solution. X is less than 0. Here's negative 2, and here is 2. I just write it. So x is less than or equal to negative 2. I have a solid point, solid dot, and then I mark this area. So that's your solution. This is the example number 8. All right, now we're going to deal with some more complicated situation. Let's work on number 9. I made things up, which is 2x minus 4 is less than 5. This one is not as obvious as the first 8 examples, but we won't we won't be scared. We know how to do it. I remember when we do 2x minus 4 equals 5, we add a 4 on both sides first, and we divide by 2. We do the same thing. So we add a 4 first. When you add number or minus, add or subtract a number, and you still keep that inequality sign. So we have 2x is less than 9. All right, then the next step, you're going to divide it by 2, divided by 2, and the 2x divided by 2, that's a positive number, so I still have that. So I have x is less than 9 over 2, or you can say x is less than 4.5. It's the same thing. So when you draw, here is 0, here is 9 over 2. Okay, so that's going to be a circle, and then you're going to mark to the left of it because it's less than. Sounds good? This is number 9. I have some space, so I'm going to write here. So number 10. What about I have this 2 times x minus 4 less than 5. This is the difference between these two. Okay, this is like the linear thing is obvious, but this one has a parenthesis, and that is okay. We can also distribute this. We're not changing anything. I just rewrite that by distributing 2 into this parenthesis. I am not changing anything, so I can still just write everything else there. And then it becomes very similar to the situation we had earlier with plus 8. So we have 2x less than 13. You can say we move negative 8 to another side, or plus 8 on both sides. It was the same thing. When you plus or minus a number, then you still keep this direction. And next you're going to divide by 2, which is a positive number. So you have x is less than 13 over 2. And that's it, or 6.5. So x 0, here, 13 over 5. And then less than that, so it's a circle, and then you're going to mark to the left of it. All right, so this is number example 10. So we work on one more. I just try to make sure that you know how to solve all kinds of inequality problems. Okay, so the last one, number 11, which is I make it a very complicated. Okay, it's going to be 3x minus 1 is greater than 2 times x plus 1. Phew, we have x on both sides and we have a parenthesis, and usually we just get rid of this parenthesis by distributing 2 inside. So we have 3x minus 1 greater than, distribute 2, we have 2x plus 2. Okay, then I am going to subtract 2x on both sides. Now quick question, when I subtract 2x on both sides, do I change the direction? No, you don't. When you do plus minus, you don't change the direction. So you minus 2x, or you move 2x to the other side to become a negative 2x. It's the same thing. This part will be canceled out, and this is the 3x minus 2x. I have an x minus 1. I just drop it, and a greater than 2. And the next I'm going to add 1 to both sides. So I will have x is greater than 3. Again, I don't change the direction. So the answer is x is greater than 3, and that's a 0. Here's a 3, and it's a circle. And then I'm going to mark the part to the right of it. So this is x greater than 3. I think this might be the most complicated situation. And of course, sometimes when you do this and you have a negatives, and whenever you have that, you know what to do already. And so far, I think we know everything about how to use all the properties of the inequality to solve the inequalities. We're very, very good. You should be very happy. All right, the next concept is a new one. It's called compound inequalities. This is a new thing. We don't have that in. We don't have this for the equation part. What does that mean? Let me give you one example. 1 is less than, x is less than 2. Okay, this one. You can tell what it's saying is x is between 1 and 2. X is greater than 1, and at the same time, x has to be less than 2. If you want to show that on the number line, that is a 0. Here's a 1. Here's a 2. Okay, and there's no equal, so you have 2 circles here, and between them, see, that is x is between 1 and 2, and exclusive, which means it cannot be. What about this one? What about 1 is less than x, less than or equal to 2? This is also a compound inequalities. So that's 0 and 1 and 2, and x is greater than 1, right? X is greater than 1, so that's a circle, and then to the right of it, and x is less than or equal to 2, so here's a solid point, and then you shade this part. Okay, so that is a compound inequality. X is kind of like a limited, or x is, has to be between 2 numbers. There is another kind of compound inequalities, looks like this. Looks like x is less than 0 or x is greater than 1. Now these two, if x is greater than 1, that could be like a 1.1 or 5 or 10, but less than 0 is a negative number. So there's nothing in common. And when you want to draw that on the number line, so here's a 0, here's a 1, then x is less than 0, which is here, or x is greater than 1. So that x must be satisfied with both, with either this or that conditions. This is called compound inequalities. All right. After we know what is the compound inequality, of course, the next thing is we need to solve the compound inequality. let me give you the example how to solve the compound inequalities, which is this here. All right. 5 is less than 2x plus 1 is less than 9. Can you solve this? For this inequality, we know how to do it, and for this inequality, we know how to do it, which we use something we learned earlier, right? And when we have this compound inequality, especially when you have something is between two numbers, and then what you need to do is very similar step, you're going to minus 1. However, you need to do that everywhere, in all three places. So you have 2x. Remember, plus or minus the same number, then the sign keeps the same. Okay, and that will be 4 and 8. All right, so you minus 1 first, and the next one you're going to divide it by 2, divide it by 2, and divide it by 2. All right, so you have, when you divide it by a positive number, you still keep the direction. So you have 2 is less than x is less than 4, and that's that x, x. And here's a 0, here's 2, here's a 4, and that's a circle in between. All right, so this is how to solve the compound. Let me ask you a quick question. What happens if you have a negative 2 here? If you have 5 less than 2, let me just change it. What do you have? 5 is less than negative 2x plus 1 less than 9. Well, of course, you're going to minus 1 first, just like what we did earlier. So you have a 4 is less than negative 2x is less than 8. Next, you need divided by negative 2. And the same thing, divided by negative 2 everywhere. And since you are divided by a negative number, you're going to change the sign. So here will be x, and this is going to be greater than, this is going to be greater than, and a 4 over negative 2 is negative 2, and the 8 over negative 2 is negative 4. So negative 2 is greater than x is greater than negative 4. If you want to show that on the number line, here's x, and here's a 0, and here's negative 2, here's negative 4, then it's going to be circle between them. Okay, you see? When you divide it by a negative number, you're going to change the directions. So that's the how do you solve it? If you have the other type of inequalities like I showed you earlier, if you have something like this, and you don't have x, you have something more complicated like 3x plus 1 greater than 1 and something, you just solve them one by one. So what we need to exercise is this type of inequality, which we don't have that in the equation part. We're going to solve for this compound inequality with absolute value 2 less than or equal to negative x, negative 1 less than or equal to 3. We don't do that. No. Okay, we're going to work on the next compound inequalities. This one, 2 less than or equal to negative x minus 1 less than or equal to 3. This is a compound inequalities. The first step, we're going to plus 1 on both sides. So, I'm doing so fast. So it's a 3 less than or equal to negative x less than or equal to 4. And then since I have a negative x, so my next step is going to multiply by a negative 1. Multiply by a negative 1. or multiply by a negative 1 everywhere. When you multiply by a negative number, you change the direction, right? So you have x greater than or equal to negative 4 and greater than or equal to negative 3. All right, so you draw. Here's 0, negative 1, 2, 3, 4, negative 3, negative 4. We have x should be between negative 3 and a negative 4, and a solid. We have a 2 solid line and in between. And that's the answer. Right, this is for this inequality, for this compound inequality. Let me give you another interesting inequality, compound inequality problem in the real life. For example, we know water will get frozen at 0 degree Celsius and become the steam or vapor after 100 degree. So that is when C Celsius degree is less than or equal to 100, greater than or equal to 0. That's water. It's a liquid. So we also know the Fahrenheit. I would need to know what is the range, what is the interval in the Fahrenheit measurement that the water is the liquid form. Now I know some formula. I know this C. How do we get a C? That is F minus 32 times 5 over 9, okay, or F minus 32 divided by 1.8, and that's a C. I think I like this one better. Okay, divided by 32, minus 32, then divided by 1.8. Let's just substitute a C here. So I have a 0 less than or equal to F minus 32 times 1.8 less than or equal to 100. So I already changed by substituting this. I already changed from this compound inequality to this one. This one is about a Fahrenheit. And to solve this, we multiply by 1.8, which is a positive number, so I don't change the direction. And a 1.8 times 0, I still have a 0. Less than or equal to F is here, F less than 32. And less than or equal to, multiply by 1.8, I have 180. The next step, I'm going to add a 32, so F would be from 32 degree to 180 plus 32 is 212. Okay, so when the temperature in Fahrenheit is between 32 degree and 212 degree, water is the liquid form. Water is in liquid form. So that's a very interesting example. All right, next one will be a new concept, absolute value. You might think, well, absolute value, I know that, absolute value. But what we're going to talk about is the absolute value equations and inequalities. We haven't learned that yet. Okay, we talk about the absolute value equations. For absolute value equations, let me give you some simple one. Okay, what is the solution to this absolute value equation? X absolute value equals 5. What is X? You know that X should be 5, or X equals negative 5. Because we know positive 5 and negative 5 both have the absolute value of 5. So if you have the equation like this, X absolute value equals 5, then you have two solutions. Okay, you have positive 5 and negative 5. What about this? Absolute value of X equals 0. Then what is X? There's only one solution for that. 0. You don't have positive and negative 0. It's just 0. All right, now what about if I ask you to solve this one? Absolute value of X is negative 5. we know all the absolute values must be either 0 or positive. It cannot be negative. So there's no way we can find any x. We take the absolute value of it, we get a negative number. So for this one, it's going to be no solution. Okay? So this is the easiest absolute value equation. Now, how about I give you a little bit complicated one? Because I have some space, I'm just right here. What about this? 2x plus 1 absolute value equals 5. How do I solve that? All right, now I ask you to do this first. Sum absolute value equals 5, then that something should be either 5 or negative 5. So you have 2x plus 1 is 5, or 2x plus 1 equals negative 5. Then you know how to solve it, right? You minus 1, so you have 2x equals 4, and you get x equals 2. And here you minus 1 on both sides, you get a 2x equals minus 6. You have x equals negative 3. So that's your two solutions for these absolute value equations. I think maybe I give you one more, a couple more. All right. So what about if I ask you to solve 2x plus 1 equals 0? Solve this. And then you're going to remember when you have the absolute value equals 0, then whatever inside the absolute value, 2 bars, has to be 0. So 2x plus 1. That's only choice. It has to be 0. So minus 1, and then you have 2x equals minus 1, and then x equals negative 1 over 2. And that's your only answer. What about if I give you this one, 2x plus 1 equals negative 5? There's no way I can find any x value, even I multiply by 2 and a plus 1, whatever inside, I don't really care. There's no way we can find anything with absolute value to be negative. So this one, no solution. Okay, so you're going to be super careful, right? Let me go with the last one. Let's do the last one. 2 times the absolute value of 2x plus 1 minus 3 equals 7. It's very complicated, but we treat this part as a whole piece. So we have 2 times something minus 3 equals 7. So we plus 3 first. We have 2 times 2x plus 1 absolute value equals 10. Okay, so we have 2 of something. I like to call this something, it's just one whole piece. So we divide by 2 on both sides, so we can get rid of that. Therefore, we have 2x plus 1 equals 5. Then it goes back to what do we know? We have 2x plus 1 equals 5, or 2x plus 1 equals negative 5, right? That's the absolute value we know. And then minus 1, 2x equals 4, x will be 2, and this is 2x equals negative 6. This is one, we know this already, x equals negative 3. All right, so this is the most complicated situation we could have when we deal with the absolute value equations. All right, now we are so good at absolute value equations. Now the challenge is absolute value inequalities. What about this one? Absolute value of x is less than 5. And we know if x is positive, we know like if anything less than 5 should work. If x is negative, then everything, all the x to the right of negative 5 should work. So for this solution will be this. X should be between 5 and a negative 5. Okay, so you're going to draw, here's a 0, here's a 5, and here's a negative 5. Circle and a circle and a between. Now you see why we learned this absolute inequality after we learned the compound inequalities, right? Because we need it. So x is between -5 and a +5. For every single value you picked from this interval from -5 to +5, that absolute value must be less than 5. So here's the solution, and here is how to graph that. What about this? What about absolute value is greater than or equal to 5? What about this one? Then you believe it's going to be here and here, right? Either to the right of 5 or to the left of -5. So either x is less than or equal to -5, or x is greater than or equal to 5. So that goes to this. -5, 0, and 5. So either solid less than or equal to -5, or solid greater than or equal to 5. Okay, so that's your solution. If I give you absolute value of x is less than a number, and then you know it's going to be like in between the positive and negative of that number, and that number has to be positive. And if the absolute value is greater than a value, this value has to be either 0 or positive, then it's to the outside of the plus minus that number. Okay, so this one is just for x. What about I have this? I have an absolute value of 2x minus 1 is less than 9. A absolute value of something, right? I call this a something, is less than 9, which means it's between -9, 2x minus 1, and a positive 9. Now, be very careful when you write this compound inequality. You have to make sure that this is greater than that, so you can have this less than and less than sign. All right, so don't do opposite. All right, so after we have this, then the next one will be with +1, +1, +1. So we have -8. We keep the direction, 2x minus 10. We divide it by 2. That's going to be 5 and a -4. So we have the solution, and you know how to graph that. And this is here's a 0, 1, 2, 3, 4, 5, and a -1, 2, 3, 4. So x is between -4 and a +5. So it has to be circle and a circle, and you're going to mark the line segment between them. Okay, so you have something like this. This is a absolute inequality. All right. So what about a couple more examples? What about this one? Yeah, we do a little bit more exercise. What about this one? X minus 2 is greater than or equal to 5. We have this inequality. Some absolute value is greater than or equal to 5. So you have either x minus 2 is less than or equal to -5, or x minus 2 is greater than or equal to +5, isn't it? And of course you plus 2, so you have x is less than or equal to -3, or x is greater than or equal to 7. And when you graph that, it's going to be 0, and then 1, 2, 3. Here's -3. Here's a 1, -1, 2, 3, 4, 5, 6, 7. Greater than or equal to 7 is a solid point, and then to the right. Less than or equal to -3, it's a solid point, and then to the left. Okay, so this is another one. Let's do just one more, and then I think we're going to be okay. So 3 times -2x plus 1 minus 3 is greater than 7. Phew, when you do this, let's simplify this a little bit, because this one is not as that one. This one we have the absolute value, the whole absolute value on one side, but this one we have this we have -3, we have 3. Let's get rid of that first. So we plus a 3 on both sides. Then we have 3 times -2x plus 1 greater than 10, right? and then we are going to divide it by a positive 3. So I have a negative 2x plus 1 absolute value greater than 10 over 3. Now this one looks similar to that one. So we have absolute value greater than, this is a positive number, therefore I have a negative 2x plus 1 less than negative 10 over 3, or negative 2x plus 1 greater than positive 10 over 3. And it's going to be very similar steps. We minus 1 first, so we have a negative 2x, and this one we minus 1, which means we minus another 3 over 3, so it's going to be negative 13 over 3. Okay, and this one same thing, we minus 1, so we have negative 2x greater than, we minus 1, which is 10 over 3 minus the 3 over 3, which is 7 over 3. The next step, we're going to divide it by 2. Divide by negative 2. Hey, divided by negative 2, that means you have to change the direction. So you have x is greater than 13 over 6. Or, and you divide it by negative 2, so you're going to have x is less than 7 over negative 6. Alright, and of course you can draw x, here's 0, and 13 over 6 is slightly more than 2, so it's here, and it's greater, so it's a circle to the right. And this one, 7 over negative 6, is somewhere a little bit to the left of negative 1, somewhere here, and then you're going to shade, you're going to mark this area. Okay, so this is I think this is the most complicated situation you probably will see when you deal with the absolute value equations and inequalities. Okay. We learned most of the part in this class to solve linear equation inequalities and graphing. I keep graph that inequalities, but this one is a little different. This is the last part of this chapter or of this class. It's graph linear inequalities in 2 variables. Graph linear inequalities in 2 variables. What does that mean? If I ask you to just can you show me the graph that x is greater than 2? You say, yeah, I can do that. I got a 0 and a 1, and here is that, 2. So x is greater than 2. Right? We just learned this. What about in 2 variable, which means you have x and y, and that is a space. So this is a 1-dimensional space. This is a 2-dimensional space. This is a plane that has both x and y. This one, the one we keep using this to show the interval part, and that is 1 dimension. So if I ask you to draw x greater than 2 in 1 variable, it's just the 1-dimensional space. You just draw this. But if I ask you to draw that x greater than 2 in this 2-dimensional space, it's going to be like this. You can see it's a little complicated, huh? So here's 1, 2, 3, 1, 2, 3, negative 1, 2, 3, and a negative 1, 2, 3. Again, they might have that, 0, 1, okay, and a 1. X greater than 2. X greater than 2. Usually we just do a circle here, and then we just draw to the right. But this point, this x coordinate of this point is also greater than 2. So this point also satisfies that x is greater than 2. So the graph will look like this. Did you notice that I didn't draw a solid line? I used dotted line, and then I shade the whole area to the right of it. And that area is x is greater than 2. That makes sense? Because for every single point in this 2-variable space or 2-dimensional space, every single point in my shaded area, that x coordinate is greater than 2. And it cannot be equal because I have this dotted line. What about if I ask you to draw x is greater than 5 in 2 variables? Then that's going to be, here's 5. I use a solid line. Solid line is when you have greater sign here. All right, so this is the very basic idea about how to draw the graph. And let's draw something more about here. Let's draw y is less than 3. Okay, so you're going to do x, y. Here's a 3. Here's a 0. Here's a 3. Y is less than 3. If in the one-dimensional space, that's going to be 0, here's a 3, you're going to put a circle, and then you're going to do this, right, for the y, right? That's what we learned earlier. But now this y is less than 3, so it's going to be something like this below. So every single point in this half plane, in this shaded half plane, its y coordinates is less than 3. Okay, makes sense? It's very interesting, isn't it? How about this? How about a hard one? 0 less than y less than or equal to less than, okay, y is between 0 and 3, inclusive. So it's going to be y is greater than or equal to 0. That means from here and up, solid, up. And less than or equal to 3 means from here, solid, and down. So it is very interesting that we have this area. And that is the graph of this compound inequality. So it's very interesting, isn't it? And from here, we notice that if you ask me to write y is greater than 0, then it's going to be all the way from here and above. And it's just really hard to put the dot on this x-axis. That's okay. This is what you need to know for at the very beginning when you need to do the graph linear inequalities. Okay, so let me give you one more example and to show you what is the general step to graph this. Y is greater than 2x minus 1. Okay, I write the step, okay? Step 1, change that into equal. All right, don't ask why. Change it to be equal because graph, we only know how to graph this line. You know how to graph? Yes. And step 3. Test point. Step 4. Shade. Okay, I will explain to you what does this mean. First step is very easy. We just, no matter whether it's greater than or less than or greater than equal to less than equal to, we just change that to be equal because we know how to graph this linear equation. And how to graph that? We have x, y, 0. We know slope is 2, y-intercept is -1. So here's -1, here's 1, and 2, and 1. So slope is 2. So when x goes to the right, go up by 1, y should go up by 2. So that goes here. Therefore, I have these 2 points. And then next, graph this and be very careful with equal. Okay, so that means if you have here is a greater than, no equal, then you're going to use a dotted line. See what I'm doing? Okay, that's your line, but it's dotted. Okay, here and that. All right, so I graph that, And then the test point, usually I choose 0, 0. If 0, 0 is not on this dotted or solid line, I choose 0, 0. What I do, I put 0, 0 back into the original inequality to see whether that is true or not. If I put x equals 0, y equals 0, here's a 0, 2 times 0 minus 1 is negative 1. Is 0 greater than negative 1? 0 greater than negative 1? Yes. So if the answer is a yes, or if the answer is true, then 0, 0 will be in your solution region, which means to the left of this dotted line is your solution region. If 0, 0 is not, 0, 0 doesn't satisfy this inequality, then 0, 0 is not, then your solution region will be to the right of that. So we shade this area, and that's my answer. Is that good? So for every single point in my shaded region that x and y coordinates satisfy this, y is greater than 2x minus 1. This is a very interesting method because we use 0, 0 to plug in. I always like to use 0, 0. If you don't want to use 0, 0, then pick any other. You can pick x equals 2, y equals 0. If you put x equals 2, y equals 0, say 2 times 2 minus 1, which is a 3, y 0, is 0 greater than 3? No, the answer is no, so this point is not in the solution region. Of course, you're going to shade this area too. So you should have exactly the same solution region. Okay, so either method, I prefer 0, 0 because it's much easier. You shade it. Let's work on another example. We do x plus 2y less than or equal to 3. Okay, this is an inequality. Step 1, x plus 2y equals 3. My first step. Step 2, graph it. I write how to graph that. Pick 2 points. So I choose when x equals 0, y is 3 over 2, and then when y equals 0, x equals 3. So I have 2 points. So it's 1, 2, 3. It's x 1, 2, 3, and for y, it's 1, 2, 3. When x equals 0, y is 3/2, which is right here. So I have 2 points already. I have 2 points. When I connect this, I want to make a line. I can put a solid line because here I have a equal. Sorry, it's less than or equal to. I have equal, so I can put a solid line, which is okay. And then the next, I'm gonna check 0, 0. If I put a 0, 0, 0 plus 2 times 0, 0 plus 0, is 0 less than or equal to 3? Is this true? The answer is true. So 0, 0, this origin must be in this solution region, so I just shade this area. That's how should I do that. Okay. I think we just do one more. This is fairly straightforward and it's not too complicated. Okay, so the last one I'm going to do is x plus 2y is greater than 0. Okay, step 1, x plus 2y equals 0. And I only need to choose 2 points. If you like, you can rewrite, move the x and divide by that, or you can get the slope. You can get the slope-intercept form, but you don't really need to. And first of all, you can put if x equals 0, then y must be 0 because here's a 0, 2y is a 0, so y is 0. Well, I have this origin in that. Okay, y. And the other one, I just pick any. I choose y equals 1. If y is 1, here's a 2, so x is negative 2. That means negative 2 and 1. 2, 1 is here. Okay, so I have this point and this point, and there's a greater than, so there's no equal sign, so I'm going to do a dotted line. Now I have this, either this region or this region, but the funny thing is I cannot use 0, 0 to test it. So I choose here, I choose x equals 0, y equals 1. When x equals 0, y equals 1, I have x equals 0, y equals 1, so 0 plus 2. So is 2 greater than 0? The answer is true, so this point must be in the solution region, so we know the solution region should be here. Okay, so this is the interesting graphing part, and once we finish this, we're done for this class. I think so far we have finished all the single equation, or the linear equations. We learn how to solve it, we learn how to graph it, and we learn how to write it. And also for this class today, we learned the inequality, and we learned how to solve it and graph it. We know how to graph that in the one-dimensional space, and then we know how to graph that in the two-dimensional space. So that's all for today. Thank you.